Hello students, welcome back. Let us continue with chapter 10, circles. We will take a look at a new concept, perpendiculars drawn from the center to a chord. So, for this we have two theorems, one is the theorem and the other one is the converse, but first let us understand what are perpendiculars drawn from the center to a chord. Let's say you have a circle. So, you have a circle with center O and you have taken a chord, let's say AB. Now what you have to do is draw this circle on a piece of paper with center O and chord AB. Now with this line as the diameter, so call this PQ. So along PQ you fold this circle. So how will the circle look like? The circle, when you fold it, it will look somewhat like this, right? You will notice that this point out here, AM will be equal to MB and this is the perpendicular. Okay, so based on this we will prove a theorem that the perpendicular drawn from the center of the circle to the chord is bisects the chord. So let's write this down. This is theorem 10.3. The perpendicular drawn from the center of the circle to the chord bisects the chord. So what you are going to do is you will draw a circle with center O, chord AB, and you will draw a perpendicular. Now the given is what? That O is the center of this circle and AB is the chord such that OM is the perpendicular to AB. You need to prove that MA is equal to MB. So how will you prove that MA is equal to MB? Just draw these two triangles. So which are your two triangles? AOM and BOM. So if you notice, AO is equal to BO because they are the radii of the circle. Here you have OMA and OMB as right angle triangles and OM is equal to OM because it's a common side. Therefore, you can prove the two triangles congruent to each other by the hypotenuse side test. Because the hypotenuse are equal, this is a right angle triangle and one side is equal. So once you prove that the two triangles are congruent, you can say that AM is equal to BM. Therefore, you can prove that the perpendicular drawn from the center of the circle to the chord bisects the chord. Let's write the proof. So I'll say given O is the center of circle, AB is the chord, OM is perpendicular to AB and M lies between A and B. To prove that AM is equal to BM. So you will say proof and you will first write the construction, join OA and OB. So you will say draw OA and OB. Now in triangles OAM and triangle OBM, OA is equal to OB, radii of the circle. Also you have hypotenuse. So these were the hypotenuse, right? Hypotenuse OA is equal to hypotenuse OB. Then you have OM is equal to OM. It's the common side. and you have angle OMA is equal to angle OMB is equal to 90 degrees. Therefore, triangle OAM is congruent to triangle OBM by hypotenuse side test or right angle hypotenuse side test. So, you can even say RHS test. Therefore, what can I say? That AM is equal to BM by corresponding paths of congruent triangles or CPCT. So, what did we learn? That if you draw a perpendicular from the center of the circle to the chord, this perpendicular will bisect the chord. So, let us see if the converse is true, and that will be theorem 10.4 of your textbooks. So, let us write down theorem 10.4. A line drawn from center of the circle, to bisect the chord is perpendicular to the chord. So, what are you going to do here? You will draw your circle, right? You will mark the center as O. You will take your chord AB, and it's been given that the line drawn from the center of the circle to the chord. So, OM is the line drawn from the center of the circle to the chord is bisecting the chord. This is been given. Line drawn from the center of the circle to bisect the chord. Now, you need to prove that each of these angles OMA and OMB are equal to 90 degrees. So, what are you going to do is you are going to draw points OA and OB to form line segments OA and OB. So, now what you are going to do is prove the two triangles congruent. You can very clearly see that these two triangles are congruent to each other by the side test of congruence. How? Here we have the radii. MA is equal to MB is given, and this is the common side. Therefore, the two triangles are congruent to each other by the side test of congruence. Therefore, angle OMA is equal to angle OMB, right, through corresponding parts of congruent triangles. But OMA plus OMB is a linear pair because AB is a straight line and MO is the line standing on it. Therefore, the sum of these two angles is 180 degrees. But since these two angles are each 90 degrees, each of these angles are equal to each other. That means each of these angles is 90 degrees. Therefore, OM is perpendicular to OB. Hence, our theorem 10.4 is proved. So, let us go ahead and write the proof. Given in a circle with center O and chord AB, OM bisects AB such that M lies between A and B. To prove that, angle OMA is equal to angle OMB is equal to 90 degrees. So, I will say proof, and first we will write about the construction. So, I will say draw OA and OB, and then I will say in triangles OMA and triangle OMB, I have OA is equal to OB because they are the radii of the circle. Then I have OM is equal to OM since it's the common side, and also I have MA is equal to MB. Why? Since OM bisects AB. Therefore, triangle OMA is congruent to triangle OMB by the side or SSS test of congruence. Therefore, angle OMA is equal to angle OMB by corresponding parts of congruent triangles or CPCT. Right? Let's mark this as 1. But angle OMA plus angle OMB is equal to 180 degrees. Why? Because of linear pair. Let's mark this as 2. So from 1 and 2, what do you get? Instead of OMA, I will write OMB over here. So I will get, therefore, angle OMB plus angle OMB is equal to 180 degrees. And I'll say from 1 and 2. Correct? Now this is 1 apple plus another apple, that makes it 2 apples. So twice angle OMB is equal to 180 degrees. Right? So let's solve this over here since we do not have enough space. Now therefore angle OMB is equal to 180 degrees divided by 2, which is equal to 90 degrees. Correct? Therefore angle OMB is equal to angle OMA is equal to 90 degrees. And I will say from 1. And here, let's mark this, let's say this statement as 3. So from 1 and 3. Hence, we have proved. So we have proved 2 theorems out here, Theorem 10.3 and Theorem 10.4. This one is the converse of this theorem. Let's revise the statements. The perpendicular drawn from the center of the circle to the chord bisects the chord. And if you draw a line from the center of the circle to bisect the chord, then the chord is then this line is perpendicular to the chord. So this line is perpendicular to the chord. So this was about perpendiculars drawn from the center of the circle to the chord. We will take a look at the other topics in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.